My name is Neil Njoshampule, and this is a project I did using neural networks to read an image of a number and output what that number is. The reason why I used a neural network over a machine learning algorithm is because with machine learning algorithms, when solving problems, you have to pick the correct algorithm in order to best solve that problem. Otherwise, it might not be accurate. However, with neural networks, if you feed in the data and the output to the correct type of neural network, it'll be able to figure out the algorithm on its own. Neural networks are modeled after human brains, so it's basically the code version of a bunch of brain cells connected to each other. I'm not going to go into the details of how they work right now in this video, but I will in another. Alright, so here's the code, and as you can see, we use the MNIST data classification set from Tensorflow. Tensorflow is essentially a library that is used to build out neural networks, and it also has data sets for learning it, right? Like MNIST. So here what I'm doing is I'm loading the data and isolating the training data set as well as the test data set. And as you know from math class, X is the inputs to an equation and Y is basically the answer. So now we're looking at the data because it's a lot of data because it's feeding in and pulling images. I'm not going to run it here. So it's three-dimensional array. So it's a three-dimensional array. So if you were to write that in any other language, it would be probably array of 60,000 by 28 by 28. So the first dimension is basically the images. The second one is the columns, and the third is the rows, right? And that's making up the actual entire image that we're being fed in. So here with these functions like endim, I'm finding out the number of dimensions, and then we find out the shape, which is the actual size of the different elements of the array for the training set and the test set. So the training set has 60,000 as we got it before, and the test set has 10,000, right, images. And now we're looking at an example image from the set by plotting it. And I'm using the train data set, the first image, 0, and then we plot it into this image. So as you can see, this is a 5, and it's labeled 5, right? So what's happening in this image set is that there's a bunch of drawn numbers drawn in different ways as if you would be writing it in on paper. And by feeding into the neural network, it's going to isolate different features of those images so that it could read writing, basically, if you feed in the actual image into a computer. So it could read human writing and determine what each of those characters in the writing are for numbers. So now, since we're using a neural network and it is built out in layers, so we'll have a layer of brain cells, code brain cells, followed by another layer of code brain cells, followed by another layer of code brain cells, and all those cells are connected to the next layer, and so on, right? We need to flatten the inputs because they're only connected to the input layer, right? So we need the actual pixels of the image fed into all the actual different nodes. So that's what we're doing here. We're taking the X data, or the image, and we're reshaping it into a single row, right? And then we're setting that as the X train array, and then we're doing the same for the test data and reshaping it into a single one-dimensional array, and we're setting that into the X test data. So now we're looking at the Y train data, which is already one-dimensional since it's just the outputs, right? And we'll see the different numbers that it is in there, right? So now what we're going to do is use one-hot encoding to encode the outputs so that it's all numerical, right? And next we're going to build out the actual neural network. and in this case we're using a sequential neural network, and we're building out the layers to it. We're adding the layers to it, right? And here what we're doing is compiling it, right? We're building it out, and then we're fitting the model like before with the X train data and the Y train data. So we're training the model like we would with the machine learning algorithm. And now that we've built it out, we're going to test the accuracy. So then we put in the actual, we feed into the model the test data and its outputs, right? And then we find out the loss and the accuracy. And then we print it out. It's around 94% accurate, which is all right, right? And then we're checking if we can actually add a layer and it'll improve the accuracy. So we do that and we recompile it, right? And now we take the metrics of it, and it's 96% accurate based on the data. So like with the actual iris data that we looked through before, it's very similar actually, but in this, so we would have for the image, we would have the image here, and then we would have the label of what it is, right? So basically we got an accuracy measure of it. So yeah, that's the number reading neural network. It's a lot easier these days. The first time I ever did this, I had to code it out all in C, right, from scratch with the numbers and everything. But this time, fast forward to 2025, you have Python libraries and Jupyter notebooks that makes things like this much easier. All right, until next time, that was a neural networks example of reading a number of a project I did for learning and updating my skill set.